In kinematics, we're mostly thinking about situations where there's acceleration and how that affects motion, how it affects distance and velocity. The first variable that we think about a lot is initial velocity. Because we're thinking about acceleration, velocity will change. So initial velocity is the velocity at the beginning. VF is the final velocity. Both of these have units meters per second. A stands for acceleration. That has the units meters per second squared. D stands for displacement. That's in meters. And T stands for time. Often we like to write T with a little foot on there to distinguish it from a plus sign. Let's look at the very first kinematic equation. The equation says VF equals VI plus AT. There it is. This is the first of the great equations that we are being introduced to in AP Physics. Let's look at a couple of examples and see how this applies to some certain situations. Let's imagine there's a guy standing at the top of a cliff and he's holding a ball. And he holds this ball and he's going to drop it. And it begins to fall. Let's say the ball falls for 3 seconds. How fast will the ball be traveling, falling, after 3 seconds? This equation up here can tell us the answer. Now, if we look at the equation, we see there's 4 variables: v final, v initial, acceleration, and time. So we need to fill in stuff for all the variables, but we're looking for the final velocity. So let's think about these 3 variables one by one. Firstly, v initial. What's the initial velocity? It's actually 0. I said this person was holding a ball and they dropped it. At this moment, when they let their hands go of the ball, it's not moving at all. So in this circumstance, the initial velocity is 0. Now the acceleration here is the acceleration due to gravity that we often call g. In AP Physics, we take g as 10 meters per second squared. Now you may have seen g is written as 9.8 meters per second squared or 9.81 meters per second squared in other courses or places, and that's correct. In AP Physics, you're actually allowed to use any of those numbers, but 10 is the easiest one. We're actually going to emphasize understanding complicated physics ideas rather than numbers and equations. So they're actually kind of helping us out by simplifying a bunch of equations by using g as 10. So if you want to use 9.8, it'll be marked right on an AP Physics exam. But we're allowed to use 10, and they recommend that we use 10 because it's easier. So we're going to use g as 10 meters per second squared in this equation. The last thing we need to put in there is the time. Time is 3 seconds. So now we're able to take these numbers and plug them into the equation to calculate for the final velocity. So we get 0 plus 10 times 3, that's 0 plus 30. All right, so the final velocity of this ball here is going to be 30 meters per second. Great. The best way to improve your grades is with a practice test. On my site, I have a free kinematics practice test. Click the link below to get yours today. Let's imagine this person throws the ball down. Maybe they're angry at somebody on a cliff and they're just throwing a ball in their anger. What do you do when you're angry? Let's say this person throws the ball at 12 meters per second as the initial velocity, but it still goes for 3 seconds in total time. What will the velocity of the ball be after 3 seconds? Again, we can take these variables and plug them into our formula. Initial velocity is 12, acceleration is 10 meters per second squared, and the time is 3 seconds. So let's put those in the formula. So V final is 12 plus 3 times 10. That's going to be 12 plus 30. The final velocity is 42 meters per second. Wonderful. So because the person added an initial velocity, there's the same amount of acceleration, and the final velocity is greater than in the first example, where it was 30 meters per second. We can also use this equation to calculate other variables For example, we might have a situation where we need to calculate the acceleration. Let's imagine there's a car that's going at 10 meters per second and it hits the gas. It starts accelerating. After 2.5 seconds, it's now traveling at 30 meters per second that way, going faster. So this is the initial velocity, this is the final velocity, so we could calculate the acceleration. Let's put these numbers into the equation. Final velocity is 30, initial velocity is 10, plus a times 2.5. So now we just got to do some algebra. Let's move 10 over. So I get 20 equals 2.5a divided by 2.5. A is 8 meters per second squared after we do that. That was the first kinematics equation. How was that? Do you feel like you understand it and acceleration a bit better now? If you have any questions, type them in the comments section below.